everyone. Let's look at this example of the power of powers property. Whoa, there's a lot of stuff in there. And if we raise it to the mth power, we're going to get 1. Jeez, how's that going to work out? Hey, wait! Isn't there a specific rule about raising powers to something powers and then it gives us 1? Oh yeah, that's right. It's the zero power property. Anything raised to the zero power is 1. Hey, this one actually was a lot nicer than it looked. So m must just be 0 because all of this to the 0 power would be 1. That one's a freebie. Next one, slightly less nice, but not too bad. Let's take a look at it. Let's see if we can notice anything happening here. Looking at both sides of the equals, and I see a 4 on top, then a 4 on the bottom. I see an x to the negative 6 on top, then an x to the negative 6th on the bottom. What else do I see? I see x to the negative 12th on the bottom, x to the negative 12th on the top. Oh, look. Everything that we find seems to have flipped. Well, what kind of exponent would just flip everything but not change, like, the values, really? It's not, the exponents themselves aren't changing and the coefficients aren't changing. They just flipped sides. That must be just an exponent of negative 1. So, when we see reciprocals, a negative exponent would be in order here. Okay, what about for this example? Well, if we had taken this on the right-hand side, the 6, and distributed it to both the numerator and the denominator, well, we would get x to the 6th, y to the 6th. And you're looking at the left side and you're saying, well, it's negative x to some power and negative y to some power. Well, since our powers are all even, the negative really will be the same as not having the negative there. So m must be 6 here. That would be what's going to make this equivalent. Okay, now let's get into a real heavy one. All right, so I don't see things as readily comparable on left and right side of the equal sign. So let's go ahead and simplify the left side of the equal sign first. I see there's my y to the m. We're going to really be looking to find that value. So let's take it a piece at a time here. We have 4 over 8. That would be 1 over 2, or just a 2 on the bottom if you wanted to ignore the 1 for a second. What else can we do? The x to the negative 6 to be x to the 6 on the bottom, and we'll leave the y to the 2nd up top. We still have this y to the m. I'm not sure where it's going to go. And x to the 12th up top now. Okay, still to the 5th. It's a little cleaner. What else could we do? Well, if we had these x's on top and bottom, we could use the quotient property to simplify their exponents. So we have x to the 12th over x to the 6th. I'm going to put my coefficients here first. That's going to be just x to the 6th up top. Now, how would we do this with the y's? Now, remember, we end up with y to the 35th on the bottom at the end, so m must be bigger than the 2 that's in the numerator. So m is bigger, so how many are we going to have? We're going to have m minus 2 in the denominator. 2 of them would cancel with the numerator, and m minus 2 would be left in the denominator. Well, we still have it to the 5th power. So this 5 would be distributing to everything here, and that makes sense. This is how we could see the x to the 30th and the 2 to the 5th. Well, it's also going to distribute to this m minus 2 in parentheses. By distributing, we really mean it's going to be multiplied 5 times that exponent of m minus 2. So 5 times m minus 2 must be equal to 35. Whoa, heavy stuff. Okay, let's try to solve this equation. 5 times m, 5m minus 10 is equal to 35. We can add 10 to both sides, and we get 5m equals 45. And then if we divide both sides by 5, we'll get m is equal to 9. Wow, that was definitely a step up from the previous example. Let's do another one so we can practice those skills. Now, you might notice right away the important things that we need to focus on are the y's, because the y's have this variable m as their exponent, and m is what we're looking for in these problems. So if I just focus my attention on y to the 2m over y to the m, well, if I applied the quotient property to those, my answer is going to have to end up with y to the 15th on the bottom on the other side. So y to the 2m over y to the m, 2m minus m is just m. So we'd really just have, and I can write it out, right, to the 2m minus m, just so you can see that there, to the 5th. And on the other side, it's y to the 15th on the bottom. So if we simplify it inside first, that's y to the m to the 5th, or y to the 5m. All right, so 5m is on this side, and that's kind of equal to 1 over y to the 15th. So somehow we got to get the 15 on the bottom. So if we're going to go from something that's 5m, kind of in the numerator, to 15 on the bottom, m is going to have to be negative. And what's going to take us from 5 to 15 is 3. So you could think, you could think of this as 5m is equal to almost negative 15, because that 15 on the bottom is like negative 15 on the top. Hey, we can divide it by 5, and there we go. We see it again. M must be negative 3. That took some thinking and some deep diving, but thanks for sticking with it with me, and hopefully this helps you with other examples.